Dear students, today we will discuss Joule's law of heating. Joule's law of heating formula is given already. H equal to I squared RT. Its definition is this one only. When current passes in a conductor, it produces heat. That heat is directly proportional to the square of the current and directly proportional to the resistance and directly proportional to the time for which the current flows through the resistor. Once again, I tell you, heat is produced in a conductor when current passes. Then how much heat will be produced? That heat is directly proportional to the square of the current passes through it. And second point is that heat is directly proportional to the resistance of the conductor through which the current flows. And third point, that heat is directly proportional to the time for which the current flows through the resistor. So 3 points are there. For what? Heat is produced in a conductor which are proportional to three factors. One is square of the current, and second one is resistance of the conductor, and third one is time for which the current flows through the resistor. Three factors are there influencing heat. Okay, so this is Joule's law of heating. Here, example 12.10, one example is given here. Let us see. We know that power equal to V into I. Okay, keep in mind power equal to V into I. Then power equal to V into I. So V into I we divide by V. Then what will get? I will remain. V into I divide by V. Then V cancel हो जाएगा. I will remain. That means power divided by V means I. How we will get? I P equal to V into I. V into I divided by V करेंगे तो V and V will be cancelled and I will remain. That means P by V equal to I. This formula we are getting like this only. Current I equal to P by V. How we will get? Because P means V into I. Divide by V, then V and V will cancel and I will get. So question is this one only. An electric iron consumes energy at a rate of 840 watt. 840 watt power is given when heating is at the maximum rate and 360 watt when the heating is at the minimum. And the voltage is given already 220 volt. What we have to find out? We have to find out current and the resistance. Current we have to find out what is given, power is given and volt is given. Power divided by V, current only. Okay, so current to find out the current, just we have to divide the power, divide the power with the volt. Okay, so 840 divided by 220, 3.82 ampere current, we will get when heating is at maximum rate. And heating is at a minimum rate. Power, what will be the power? Power is 360. 360 divided by 220. 1.64 ampere current flows. Okay, so in this question you have to understand I equal to P by V. Okay, I equal to P by V, and P divided by I क्या होगा? Then that will be V will get. Okay, P divided by I, then we will get a V. That also you keep in mind. And in this question, P divided by V we are taking as I. Okay, and resistance. Resistance, we know resistance is V by I. V already we know 220. I 3.82. That's by 57.60 ohm resistance we are getting. And next case, 220 divided by 1.64. That is 134.15 ohm resistance we are getting. And 12.11 example you see. 100 joule of heat is produced each second in a 4 ohm resistance. Find the potential difference across the resistor. Here 100 joule of heat, that means H is already given 100 joule. and resistance of 4 ohm is given, R equal to 4 ohm, and time t equal to 1 second is given each second. That means t equal to 1 second. We have to find out the potential difference. Okay, one formula we know, according to Joule's law, H is equal to I squared RT. Okay, H is equal to I squared RT. I equal to root of H divided by RT. From that formula we will get I equal to root of H divided by RT. Then in this formula we have to apply root of H 100 divided by RT 4 into 1. Then we will get to 5. Then potential difference. Potential difference we know V equal to IR. I 5 ampere and R 4 ohm resistor 20 volt. Potential difference here we are getting. Practical applications of heating effect of electric current. Here in our daily use we are using electricity for different purpose. Okay, heating effect also that we are using. For one of the example is electric toaster, electric oven, electric kettle, electric heater are some examples uh, of using the Joule's law of heating. Okay, so these are the some examples, some useful applications in our daily use, that is electric laundry iron, also electric iron, and electric toaster, electric oven, and electric kettle, electric heater. These are the some examples of heating effect of electric current. And next paragraph they are telling electric bulb also. Okay, filament type of bulb. And in this case, they are telling that the high melting point, like tungsten melting point is 3000. 380 degrees Celsius. That means a high melting point. That means at a minimum temperature, at a low temperature, it won't melt. So high melting point tungsten has. That's why we are using this tungsten as a filament in the electric bulb. When heat is produced, more and more heat is produced, tungsten metal won't be melted. Okay, then after producing a very hot, very large amount of heat, it produces start producing light. Okay, light. And in bulb, we are giving the nitrogen or argon gases to prolong the life of element. What purpose? If nitrogen and argon gases are inert gases which do not react with this tungsten material. So tungsten materials, the tungsten metal will remain as tungsten without any chemical reaction. That's why we are using the nitrogen and argon gases. For what purpose? Means to get a prolonged life of the filament. That's why inside the bulb we keep nitrogen or argon gases. Okay, once again I tell you, in bulb nitrogen or argon gases we are keeping. Keep in mind that one is these two gases are inert gases which do not react easily with the tungsten. That's why do not react, and moreover it helps to get the prolonged life of the filament. Okay, another one is another heating effect. Another example is a fuse is also, we can say that is a using as a device used by the Joule's law of heating effect. One device is a fuse also. Okay, here mm, 1 ampere, 2 ampere, 3 ampere, 5 ampere, 10 ampere, like that different domestic purpose fuses are there. And one device which is consuming 4.54 ampere current. So which type of fuse we have to use? That is 5 ampere fuse we have to use. Why? Because 4.54 is very nearest to the 5 ampere. Okay, 4.54 current that device requires. So nearest one is a 5. So 5 ampere fuse if you are using, more current when it is flows, then this fuse will melt and the device will be safe. And if you use less ampere fuse, then what will happen? The device won't work. The fuse get melted away very soon. Then the device won't work. Device need 4.54 ampere. Then we have to use just more than that ampere fuse we have to use. Nearest to that greater than that is must be greater than that device ampere. Here device ampere is given 4.54 ampere current the device need. Then we have to use more than that ampere fuse we have to use. Okay. More than means so not much more than, very nearest to this figure we have fuse we have to use. Okay. And this type of question also normally they are asking which of the fuse is better fuse, which one of the better fuse we can use in a circuit. So we have to find out the current and just above which fuse is given in the option that you have to mark. Once again I tell you 4.54 ampere current the device requires. Then we have to use just above that ampere fuse we have to use. Okay. And electric power we will study the next day.